Utsuki. I will change the format how I make my Godot tutorials, hoping to make it less boring. And in this video, I'm gonna show you how can you make a spawner system. So everything I will do here will be on 2D dimension, but you can change and adapt it to 3D as well. So the first thing, I will create a 2D scene for as my world. Create a folder called variations. I'll create a new scene, 2D scene with sprite 2D, and I will repeat this process 3 more times to create 3 other variations of the same entity. Create a script called entity with 2 variables called timer and time limit to create my default timer. And in the process function, I check if the timer is greater than 0. If it is, I decrement by delta. Else, I reset the timer to the time limit and I set a random global position to the entity. I created 4 entities, as I said, the common, uncommon, legendary, rare, and legendary, and I will attach each one of them with this script to move to a random location. Create a folder called spawn system for all scripts related to it. Created a script of type resource called spawn variation. So I have the name, the group, the timer, time limit, the packed scene I want to instantiate, my triad of active, so active boolean equals to false, use active function boolean equals to false, and an active function that is a callable. This callable would return true or false, and in order to use the use active function flag should be true. A spawner node 2D equals to true, so this one is not exported because since I'm in the resource script, I cannot export nodes. And 5 int variables, the remaining and limit equals to -1, alive, total, and proportion equals to 0. The proportion one I didn't use here. So I have the process, I have the update function that works like a process, but since I'm not a node, I cannot use the process function. I check if it is not active or if I am using the active function and active function.call is not true, I return. If it is, I check if the timer is greater than 0. If it is, I decrement by delta, else I set the timer equal to time limit and I call the spawn function. So I have these 3 sequence of ifs just for sake of readability, okay, but you could merge into one. So I check if the remaining is different for -1, so if it is set, and if it is equals to 0, so if it is, there is no remaining spawning and a return. The same for the limit, so if the limit is different from -1 and the alive entities is greater or equals to the limit, I return. I didn't use the equals and actually use the greater because things happen. So if I spawn twice, for example, this would be enough to this not being checked, okay? And I check if the spawner is set, if not set, and or if the spawner.getTree is not set. If not, I return. So I created the variable instance equals to in my scene.instantiate. If name is set, I set the instance name equals to the name underscore the total one, using the format to use the string literal. So I have the dictionary with the key and the value I want to replace inside of the string. If the group is set, I add the instantiated entity to that group. I connect the signal tree exited to the function that will decrement by 1 the alive variable. So this signal is sent before the node is removed from the tree is seen, so before it is kill free. I add the child to the instance. I update the instance.global position to vector2.0. I increment the total and the alive, and if the remaining is greater than 0, I decrement by 1. So I will hold my variable folder, create new resource, the spawn variation, and I will rename this one to entity1, for example. So this I will call, for example, common group spawner 1, for example. I will set the time limit to the timer to .5, so I want instantly spawn, and the time limit to 2. I will load the scene I want to spawn, so in this case the common. I won't use the active function, so I will just set the active to true. And let's test. So I created a script for the word. So here I created a variable called spawner of type spawn variation equals to load the resource I just created. In the ready function, I update the spawner equals to self. And in the process function, I check if the spawner is set. If it is, I call the update function passing delta. So now let's test. So as you can see, it should start working and it will spawn indefinitely. But now let's change, for example, the remaining. I will set the remaining to 3. So it should not spawn more than 3 entities. So as you can see, only 3 entities is spawned. So I will attach a timer node, and on the timeout, I will try to kill every single entity of the group spawner 1, and let's test the alive attribute. Here I created a timer of wait time 5 seconds and auto start and the signal timeout to this function, and here I print the total spawned entities, the alive ones. I loop in the get3.getNodes in group of the group inside of the spawner. I kill 3, and let's, for example, limit the alive, for example, to 1. So it should only spawn 1 entity that will be killed every 5 seconds, and then I will spawn only 1 again. And as you can see, the total 1 is being incremented while the alive is limited to 1. Okay, I created another script, another resource called spawn option, and this one is a bit more complex than the previous one, as exactly because how much complete I wanted this to be. I spent hours designing it and coding as well. So we have the spawner variable that's with the same idea of the spawner inside of the variation. The RNG that will help us to decide a lot of things throughout this script, and the group dedicated for this spawn option. So even though we have the entity group, this one is unique for the spawner. So actually we can control, we could use the groups for inside of the entity scene, another one for the spawn variation, and another one now for the spawn option. We have the triad of the active again, and here we have the point that is an array of node path and the packed float 32 array points wage. Okay, so instead of node path you could actually use node as well. So but in this case you need to manually set, remember, and adjust the code where I am using these points as well. So this points weight will be used with the RNG. I will explain later. So here we have 4 variables for the spawn point type. As you can see, we have the unknown spawn point type with iteration, random weighted, and area. The spawn point that will hold the value of the spawn type, the iterator, and spawn point is parent equals to true. Then we have the spawn decision type in iteration, random weighted, and alive weighted. The iterator equals to -1. The weights, the same idea of the point weight as well, and the spawn decision holding the enum value. An array of variations, and now we have types of timer: individual, incremented, replaceable, and common. As I said, I will explain them later. And a variable to hold the value of this enum. We have the timer limit, and the remaining limit, total, alive, repetition, and mean time gap. Okay, these last two I also used in my tower defense system video, even though I think it's way better than that. I decided to repeat this part as well, and I will explain later. Okay, so we have the update function, the same idea, but here now I check if the pointer size, my array of points, is lesser or equals to 0. So I will only spawn if I have a point, okay, a spawn point. And now I check if it is active or the active function is being used and return true, and I match the timer type. Here I only match the individual, because if it is individual, I will use the timer settings inside of the variations. Actually, I will just use the variation as I would use in the previous example, okay? So instead of having a lot of variables holding each variation, I would have only one spawn option and would set the timer option to individual, so it would work the same way. Else I will call my spawn function. So here the first if is the condensed version of that if with the limit. If the limit is different from -1, the remaining as well. The spawner is not set or is not inside of the tree. Okay, the same thing. Here I loop inside of the variations only to update the spawner equals to the spawner of this spawn option, okay? And I loop inside of the pointers just to check if every single point is inside of the current scene, okay? So if you would use the node and you would actually set it through the script, probably you wouldn't need to do it as well, okay? This is just for the node path, the way that I'm using, to not throw an exception, okay? Then a loop in the range of 0 and the repetition. So in that tower defense script, I used this repetition for the waves. So if I have a wave, for example, imagine blooms 36, for example. I have a wave where I should spawn 6 red blooms at the same time, for example. So instead of having 6 dictionaries, I just have one dictionary setting the repetition to this number. But if I don't add any gap timer or gap distance between them, every single one of them would overlap each other. So that is the mean gap timer. So here I will just show you already. Here in the end, I check if the mean time gap is greater than 0 and if the spawner exists, because I would use the getTree.createTimer passing the mean time gap and awaiting for the timeout signal, okay? So actually, for example, I use the default number in here, 1 divided by 15. You already know that the process function is called in a fixed times of 1 every frame. Actually, the process function is fixed in 30 FPS. So if I use 1 second, or in this case 1 divided by 15, it's basically 2 frames, okay? So I wait for 2 frames in order to spawn the next repetition. I increment the total and the alive variables and I check if the remaining is greater than 0, so it is set, and I decrement by 1. Then I create a variable option to hold the spawn variation. I made this because I had to decide which option I should go for and then do another thing. So I don't declare the variable and assign the value right after. Okay, I match the spawn decision. So I have the type of iteration. I have a variable called iterator, and it should increment it by 1. So this if and else right here, you probably already know, this is a ternary operation. In other languages is made by question mark and colon, condition question mark, the true value colon, false value. And on Godot we have basically true value if condition, else false condition value. So in this case I incremented by 1 if iterator is lesser than the variation size. So for example, if I have 4 variations, my array goes from the index 0 up to 3, right? So I should check if my iterator is in the limit, is lesser than the limit, that is 3. So I check if the iterator is lesser than the 4 less 1, that is 3, else I increment by the negative size of my array less 1. So here, for example, in the 4 array size example, I have 3. I would have 4 less 1, that is 3, or negative 3. And when I increment by negative number, I basically decrement. So I actually reset to 0. So this line basically increments by 1 or reset to 0. And I set the option equals to the variation array in the position of the iterator. If I'm using the type widget or a live widget, I create a variable called number that is a float just because it's needed to be, okay? And it should be equals to the alive inside of the spawner option. Else, so if I'm using the alive widget, I will use the total. So the total number instead of the alive one, okay? And I loop inside of the variations and I check the proportion, that unused variable that I set in the variation class. So I check if the proportion is lesser to the total inside of that variation divided by number. So for example, if the proportion should be 50%, I check how many I spawned of that variation, for example 3, and I divide it by the number I picked, if it is the alive one or total one. If it is lesser or equals to that number, I pick it, because if this is lesser than the correct proportion, so the other options is actually greater than this, or at least one of them is greater than the current value, okay? If my decision type is random widget, I check if the weight is set, so greater than 0, and I set the vary option is equal to variation using the RNG random widget. So basically, this rand widget from the RNG basically will have an array of options and an array of wages, and each option of the first array would have a relative number inside of this wage, and you will use to set how the proportion of it. But this, differently from the proportion variable attribute, this one is random picked. Okay, that's why actually this is a wage and the other one is a proportion. Okay, that's why I made two different things. And lastly, if it is random, I basically use the RNG to pick a random number between 0 and the variation size array less 1. So again, 0 up to 3, okay? Then I check if the timer type is different from the individual. So if it is, that basically when this function is being called, it's because it is, okay? But just use the default value of match. If you don't know, the match is the same thing of switch case statement. So, and this is the default value, an underscore. So I check if the timer option is incremented. So basically it is the time limit of the class plus the time limit of the variation. If it is replaceable, the time limit that will be used is the one inside of the variation, or if not, just the time limit of this option class, okay? Then I create a variable called point that will be a node just because I need to use the global position, okay? I don't need anything different from this. And I match the spawn point type. So if the type is iteration, I basically, the same idea of the iteration from the variations, okay? I increment by 1. If I am lesser than the maximum size less 1. If not, I decrement by total size, so basically I reset to 0. And I pick the next point inside of my point node path point array. But in this case, I said the point is equals to spawner.getTree.get current scene dot get node using the path. Okay, if you are using a node, you don't need this. Actually, you just need to assign the point equals to that node. If it is random, I use the RNG to go through to pick a random number between 0 and the point size less 1. Okay. If it is widget, I basically use the same idea of a widget of that time variation. Okay. So rng.rent widget passing array of wages. Okay. And if not, so the spawn point is of type area. Like, guys, I remembered in the I don't know how long ago, but in the past I'm pretty sure I used the class geometry 2D in order to pick a random position inside of a polygon. But I don't remember how I did this. So instead of just basically hitting my head against the wall, I used this very simple substitution. So how is this? I create a variable called vectors that is an array. And I pick 2 random points. So as you can see, the first one is basically the same idea of get node, but between 0 and the size less 1. So basically I'm picking 2 random points, and I create another variable called point. So here I pick a random number between the x global position of the first and x global position of the second. And the same thing for the y. So I pick a random number between the y of the first and the y of the second. Okay? And then I assign the global position of that point equals to this point, a variable I just created. Obviously this naming is a bit like conflicted because one is point and another one is underscore point, but works the same. Okay, so it's just to like I have a pseudo way to get a random point inside of an array. So again, I pick 2 random points, so imagine in the left and another one to the right, but it could be in any position, okay? I pick a random x number between these two and a random number between the y-axis, okay? Then I check if the option is not set because I declare the variable option equals to null, the default value, and I also do the same checking of the remaining and the limit, but inside of the set option, okay? So if the option is not set or I have that limit set, I return after all this, okay? But just because I set the option at the end of the function, okay? Then I instantiate using the packed scene. I connect the signal tree as it, just the same reason. Okay, so upon Q3, this will be decremented by 1. If the name is set, I replace, and here instead of 1 add to group, now I have 2 add to group, right? I check if that spawn point is parent is true and the point is inside of the tree. So if it is, I add the instance inside of this point, okay? If not, I check if the type is of type area. So I basically just add the instance to the scene, and then I update the global position equals to the global position of that I calculated. If not, I add the variation, the instance, to the spawner. Then I increment by 1 inside of the option, and if the okay, I don't need to decrement again. I'm sorry, I don't need this because I made this decrement in the starting, in the beginning of the repetition. Okay, I'm sorry, I didn't remember. And I also check the remaining inside of the spawn variation. Okay, so I also replaced the script inside of the word, but now I replaced the spawner variation to spawn option. So I renamed the variable and I replaced where it was needed. And instead of loading the entity 1, I now load the spawn option dot trees, okay, t resource. And I also created the other entities for the others rarity. So the entity 2 for the uncommon, the entity 3 to rare, and so on. And I also added 4 markers inside of this scene, as you can see. So now I have this small area. And in the spawn option, I set this thing, okay? So if you don't remember, basically hold the folder, create new resource, and select now the spawn point. So here I set the group equals to option 1, active equals to true. I've added all these markers to that points, okay? And the rest, the variations, I added the 4 rarities, and the rest is the default value. So now I will test every single possibility with you, okay? And then after this, we are able to go to the next step. So guys, I made this silly mistake. It's not parent, it's a spawner, okay? I am sorry. I didn't remember. Okay guys, I forgot to set this to total, okay? I was using this font, okay? That's why I made this mistake. Okay, so now let's test. This should work by default, okay? So now I have 4 entities basically being spawned randomly, okay? But nothing is set there ready or nothing like this, okay? So now let's go for one thing. I will reactivate this timer, okay? So now every 5 seconds, everything should be gone. And let's go to, for example, instead of being individual, for example, let's go to common type. So this common timer type, basically I will use the time limit I will set in here. So every single one of my variations should spawn every 3 seconds. But this is not enough because I'm using the for variable, the repetition to looping, okay? So I must set the repetition to 1, okay? So now if I press play, I should spawn the first, then the second, every 3 seconds, okay? And as you can see, I'm iterating inside of my variation. So the first one is the common, then the next is the uncommon, then the rare, and then the legendary, okay? So everything is working as expected. Instead of the common, let's use the incremented. So the incremented, basically we use the 3 of the base and increment by this number. So the first, so my entity common time limit is 2, the uncommon is 3, the legendary is 4, the rare is 4, and the legendary is 7. So depending the which entity I spawned, my time limit will be actually greater, higher, or lower, okay? So for example, common is 3 plus 5, so, okay? The uncommon is 3 plus 3. The rare is 3 plus 4. And the legendary 3 plus 7. So only after 10 seconds the next one should be spawned. Okay. Now, instead of using the incremented, let's use the replaceable. So basically, as I explained, the time limit of the class is won't be used. The one inside of the variation that will be used. So the common should be 2, the rare, the uncommon 3, the rare 4, and the legendary 7. Okay, cool. So now let me go back to the common. And let me set the remaining, for example, once again, now it's 2. So it should spawn only 2 and then don't spawn any entity after this. Okay, it's working. And instead of remaining, it's the alive limit. So it should only have 3 at the same time. Let me decrement this to 1 second, so I think it's easier to notice. So no legendary, now the legendary. Okay, so it is corrected limited. Now let me, for example, set the repetition to 5. So this should spawn 5 at the same time. Let me set the time limit to 3 again. So every time is being spawned 5, okay? But if I, for example, increase the mean time gap to, for example, 6, it should only spawn, it should spawn 5, but after each spawn, it should wait for 6 seconds. Okay. Let me use 20 seconds, okay, to the limit, so I'm able to check this time limit gap. So it should only, so the normal spawn should only happen after 20 seconds, okay? But I'm using the repetition one. So it's spawning after 5 seconds, as I said. Why is this interesting? Because, for example, if I have, as I said, if I have a wave that should spawn 10 or 20 enemies at the same time, so the repetition is 10 or 20, this time limit gap at least would allow me to control, at least let a bit of a space between them. Now let's go to the spawn decision. So instead of using the iteration of the entities, let's go for this, for example, the random one. And let me set this, it's already 2. And I turned off the random position set, okay? So, for example, let's check if I'm going from, no, I started in the legendary, then in the rare, for example, legendary again. So I'm not going from common, uncommon, rare, legendary, common, uncommon, rare, legendary. Okay, now it is being randomly picked. Okay, let's go to the random widget, for example. And the random widget use this work. I have to add to this array the wages. And for example, the sum of the wages does not need to be 1, but I will use in this way. Okay, so the common will be 70%, for example. The uncommon will be 20%, for example. The rare will be, oh, I'm sorry, it's 0.2. The rare will be 9, and the legendary will be 1, for example. Okay, so if I test, okay, common, rare, legendary, common, uncommon, common, uncommon, uncommon, common, 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 common again. Okay, basically is this. Okay, I have 70% to have a common, 20 of uncommon, 9% of rare, and 1% legendary. For the troll, for the instance of troll, the first entities were already legendary and rare, just to troll me. But as you can see, it's now very clear to be balanced. Okay, so now the widget. So this widget will be used the proportion one. Okay, lastly the alive widget, but this one I would need to turn off the auto start, for example. Let's test. Actually, we are. This is not the best way to test it, right? I think this is only being better felt if you have a huge number of entities. Okay. Okay, now let's go to the spawn point. So I'll go back. I set the iteration back again. So now I will go in that order of common, uncommon, rare, and legendary. And now let's go to the spawn point. So now it is being set random. Okay, it was it. And now let's go to the iteration one. So I will start in the upper, then in the right, then down, left, and I will be basically clockwise, right? Let me turn on this again, and I will, just to show you, okay, again, I will go back to random. So down, right, down again. It's being random, right? Now the area, so 2 random points will be picked and a random x and y between them will be set. So I will, so these markers are not exactly in the same x and y, okay, but I will exaggerate just a bit so it's better like to notice. Okay, now let's test. So, okay. So now, as you can see, it's almost like I have an area of a spawn. Okay, I'm not now having a spawn fixed spawn point. I have an area that I will pick a random x and y between these 2 points. Okay, and the random widget that I, once again, I need to add this widget. So for example, I will add in the top one 90% to spawn, then in the left, so in the right one 5%, then the bottom one will be 3%, and the left one 1%. Okay, something like this. Okay, it's random widget. So the top again, top. Okay, let's go. Okay, 90% apparently it's too much, right? So let's go, for example, to 40% here, and here will be 41%. So now I have way more chance to spawn either in the upper or in the left spawn point, okay? Yeah, it is working, thanks God. So the rest is just like the would need the active function part, right? Where you would set a random a function. For example, let me code it with you. Here in the word, for example, I create a function called return that will return a boolean, for example. Oh, I'm sorry, boolean, and it will return, for example, a. I'll have a variable a type of boolean equals to false by default. And here, for example, in the timeout, the a will become the opposite of a. So basically, it will alternate on and off. And I will set the spawner. So basically, after every 6 seconds, oh, I'm sorry, let me turn off this active. And now, every 6 seconds, I will spawn, then not spawn anymore, then spawn again. Okay, so now it's active, cleared, false again, then true. So this is how we would use the active function. The previous version of this spawner system, I actually used expression class, okay, and the expression array values. But it's just too bad, I think it's just easier to have a method that would return the value of the condition rather than have an expression and update this expression the same way that I did in the attributes multipliers, okay? So now let's go to the last step. Okay, guys, and lastly, I created this spawner. Now it is a node script, but before this, I would like to correct myself in certain things. First, in the variation, I changed two things. First, the proportion. It should not be an integer because I am dividing by a number, right? And the chances to be an float number is actually higher, okay? So I changed it to the proportion to float number, and I created a variable called position that holds a vector 2.0. Remember that here in this spawn, I used to set the global position equals to vector 2.0. Now I am using this position attribute directly, okay? Here in the spawn option, I also had to change something actually correct because here in the number I had number is equals to alive if spawn decision is equals to weighted, but not it is alive weighted. Okay, so that was a very like ugly fault of myself. Okay. Now let's go to the spawner script. So I created a scene called spawner, and I attached a script to it. So this is the script. So I have the RNG, random number generator, okay, and my active, so active, use active function, and now I have this auto next wave. So in some games, the next wave comes automatically, and some not. Open the player, click a button, or another thing happened. Okay, so here you would control. You know, as I said, I sat down and I tried to think of different games, and I tried to think as much of different types of spawning designs, okay, that I could remember. And about of the higher management of the spawner, I just could think of two types. That is the one using a spawner more general, and another one using waves, okay? So this wave one I used actually I designed first in that tower defense video, okay? So basically I have a dictionary called wave, and for each number basically represents the wave. That is an array of dictionary, and the dictionary basically can be two things: wait, that basically would create a timer, and a spawn. And the spawn have in that case a scene timer between the spawning, but in this case I try to be a bit more complete, right? So now I have the entity that must be the spawn variation, the position if you want to set the repetition, and the parent if you want to set a specific parent, okay? I have the current wave, that is the reiteration, but for the waves, right, I have this on action variable just to not conflict to the spawning, okay? To be honest, it's just to prevent error. And the wave action in num, I used this as enum because I thought I would think of more different ways to manage this spawn. But to be honest, I would only be able to thinking of these two possible things. Obviously, you have the possibility of the arbitrarily, for example, spawn, but actually you can do this in the way that I designed without actually have this thing in the spawner, actually using the spawn variation itself, okay? So, and I have an array of options, that is the spawn options. Why I have spawn options? So for example, think this spawn option actually is an array of spawn variation. So this spawn variation could group things as for their types. So for example, if you have animals, so you would have spawner options of animals. You have a spawner of a dungeon that should spawn monsters. You will have a spawn option having variations of monsters, and so on. Okay, that's why I separated in this. And this spawner, that is the one that would manage basically the whole game, must be able to manage different options. Okay, that's why it is fragmented. So I have the process now of process because I do not need because this is a node, right? So the same way I check active, or I'm using active and the active is not true, I return. I check first if I have a wave set. So if you copy or use the code that I will upload to my repo on GitHub, this example of wave would be able to block this. Okay, so if you want to use the options, you actually must set the wave equals to or empty dictionary, or just remove this dictionary, default dictionary. Okay, I basically am prioritizing the wave. Okay, if not, I check if the options has something. If so, I loop inside of the options. If the spawner of the option is not the spawner, I update it, and the RNG as well, and I call update function. Here I have the next action. So this is just for the wave, okay? So if I do not have the wave inside of my dictionary, or I am doing already an action, I return. So in the beginning, I set the action to true, and I get the next action, okay? That is the wave pop front. So with this pop front, I already remove the action from the array, so I do not need to worry to happen this more than once. And I match the type. If it is wait, I basically call wait get tree create timer, passing the timer dot timeout, connecting the timeout signal, right? If I actually spawn, I check if the empty is not empty quotes. If not, I use the timer that is the repetition and I loop inside of it. So my instance is equal to the spawn variation load. So I'm loading the resource that I should spawn. I set this spawner equals to the current scene, or if it is set in the parent equals to this parent. If I have a position inside of the wave, I update that variable that I created, position equals to this, okay, that's because I created that variable, and I call spawn inside of that spawn resource, okay? So I differently from the spawn option, here I'm using directly the spawn function from the variant, and here I also check if there is a min time gap, and I also create timer waiting for the timeout of this. In the end, so I check if the current actions size of the current wave is equal to 0. If it is, I remove the current wave, and only if the auto next wave is true, I'll go to the next one, and the on action is false. The next wave function, I check if the waves is greater than 0 and if has the next wave. If has, the current wave is iterated. And this function load wave. So it needs the paths for the file. Check if the file exists, load the file, then I create a variable data to hold the JSON.parseString, so it will try to convert the text I get from the file to a dictionary. And I also remove the current wave. Actually, I reset, okay, equals to curly braces. Then I loop inside of the dictionary, and I loop inside of the array of this dictionary. So I check if I updated the type that is a float. So even I will show you, but it's just to make sure the enum is correctly set, okay? Because enumerations is basically a dictionary of constants, right? And these constants are integers. So the get text, I think I'm not sure if it is an issue from Godot, okay? I really don't remember, but Godot basically gets every single number as float, and it is terrible. So you have to make sure it is converted to integer. So I do this in this action type equals to integer action type, okay? I check if the dictionary that action has position or x. I will show you why. If not, I return because probably is a timer. Then I create a variable called position that is a vector 2 using the action position x and y. I erase both from the action, and I set the position equal to this position, and I update the wave of this class equals to the data that is now updated every single thing, okay? So Here in the Word, I have this loading this file, and this is the file level1 wave.json. So as you can see, this would be the wave of my level 1, for example. So in the first wave, I spawn 10, as you can see, the repetition is 10 of the entity 1, and I should spawn in the coordinates 400, with the time minimum gap of 0.01, so very close to each other, right? And I will wait for 1.5 seconds in order to go to the next, in order to end this wave. So if I am doing this, the auto next wave, I would wait for 1.5 seconds before go to the next wave. And the next wave, basically 5 of the entity 2 in the 500, and 5 of the entity 3 in the position in the coordinates 600 and 600. Okay, I will turn off the, so here in my Word, I have this spawner node. I set the active equals to true, okay, and the auto next wave is on, and I will call the load wave, right? So if I hit play, I should actually basically obey the order in my JSON file, okay? So in theory, there's 10, these 5, and these 5, okay? Instead of using the wave, for example, I will remove this, and now I will use the options. So I will turn the option, so I will add this option right here in this array, right? Option 1. So now it should work as the common spawner, but as I said, this is a centralized spawner. So for example, this spawner could be friendly monsters spawner, and I could have another spawn option, and that spawn option would be unfriendly entities. I could have another spawner options that would be R spawner. I could have another spawner for like buildings spawner, and so on, okay? So now you are able to have every single thing centralized in this, okay? So guys, I spent a lot of time designing and coding this spawner. So as you might think and conclude, the scope of this is mid-long term. So I spent something around, not in this, okay, like designing, coding the first version. If I sum with this second version I did with you, I spent like 15 or 16 hours. So if I spent, for example, in every single project, 1.5 hours building a spawner for each project, only after 10 or something like this projects, this spawner system will like worth of time. And I hope actually to build more than one project that use this spawner. So I'm actually, this might not be the best if you just want to make one game, okay? Or might be, because as I said, this spawner part being centralized is very useful. So that's it. I hope this was good, like interesting for you. As I said, I will leave a link to my GitHub repo in the description. And that's it. Thank you. Bye.